All right, so I think this is recording. Let's take a look at this uniform motion problem. Read the problem carefully and identify the thing 1 and thing 2 in this. Then press continue on the video. All right, so hopefully you identified thing 1 and thing 2 as car number 18 and car number 12. All right, so let's off to the side here. Now, how come I'm not writing? Huh. Oh, maybe it's because it's on top of it. What if I put that up there? There we go. All right, so car number 18 and car number 12. All right, now fill in the information in the table here as much as you can from the information that's given in the problem, and then hit continue. All right, so hopefully you recognized that car number 18 is the winner of the Indianapolis 500. It was the first of all the cars to complete 500 miles. At that time when it completed the 500 miles, all the other cars had traveled at a lesser distance. And specifically here, car number 12 only traveled 495 miles. All right, and let's put the units up here on the top, miles. Now, the rate of each car is not given, so we're going to have to come up with an expression. We do know that the winning car had a faster rate than this losing car. Okay, let's call the rate of the winning car, let's call it X, because they're asking us to find the rate of each car, so that's going to be my variable. I'm going to solve for X. Now, that was the faster car, and it even tells us how much faster. So this is the slower car. How much slower? 1.8 miles per hour slower. So there's an expression for the rate of this losing car, number 12. I do not know the time that the race, the race took, but I know that once they said, "All right, cars, go," you start the stopwatch, and then when 18 crossed the finish line and the checkered flag came out, the race was over. So they were on the track that for the same length of time. I don't know what that time is, so I'm just going to call it T. It doesn't ask me for that time, is why I'm not calling that variable X. The one that they're asking for is the one that I choose to be the variable X. Now, I suppose we could add these two distances together and have a total distance of 995. But I don't really see any justification or reason for doing that. So I don't think this is going to get us anywhere, at least at this point. And to me, it definitely does not make sense to add the two times together, because it's not one after another. It's not like if you and I went on a road trip and I drove the first leg that was, 3 hours, and that you drove for the second leg of our road trip for 4 hours. Hey, we were riding the car for a total of 7 hours. It doesn't make sense to me to add these two times together for a total time when they were driving consecutively, or not one right after the other, simultaneously. So I don't think that this would make sense to think about the total time. So with uniform motion problems, we want to use the fact that distance equals rate times time, and sometimes we manipulate that equation to be time is equal to distance divided by rate. Same equation, just solve for a different variable t. We want to write an equation, a relationship between thing 1 and thing 2 using the information in this table, and we have one of 4 possibilities. So I want you to pick which possibility you believe we're going to use, and then press continue. All right, so So hopefully, since we were sitting here arguing that these totals down here really don't make any sense, that you didn't pick the total distance or the total time. All right. Now, if you did, pick again. Pick either the distance or the time here, and then press continue. All right. Well, we can see from the table that they didn't travel the same distance. 500 and 495 are not the same. So the relationship that I believe that we want to explore is that the race was the same length of time for each car. Now, of the two equations, the relationship written that time is equal to distance over rate is the one we want to use as well. So on the left-hand side for the thing 1, which was car 18, we want to look at the distance over rate from our information from our table over here for car 18, and we want to look at distance over rate for the other car, car 12. So 18 was the winning car. It drove a distance of 500 miles. And we said that we were going to let X be its rate. This loser car, losing car, I guess being in Indianapolis 500 is not losing, but losing to number 18. It did not complete 500 miles. It was traveling slower, an average 1.8 miles per hour slower. All right, so this type of an equation is referred to as a proportion. So go ahead and solve this and then press continue. All right, so now hopefully in solving this, you recognize that probably the technique that most students are going to pick to solve this is to cross multiply. If you multiply along this diagonal and take that product and take the product of this diagonal and set them equal to each other, that's typically how the technique we use in solving a proportion. All right, so let's go ahead and do that and then press continue. Now I'm having difficulty with this switching back and forth from the highlighter to the pen. It will not let me go back to my pen. This could be a problem. I do not know how to solve it. I don't even know how to pause the video, so you'll just have to bear with me a second and see if I can figure this out. Maybe here will it let me switch to this guy? No. I don't even know what these other things. Why is it? I don't know why it lets me move that. What the purpose of that? Or to scroll down. Oh, well, there's a lot of different. But it's not letting me change any of these. Okay, there it did. All right. So I should be in business. Okay, sorry about that. Now, 495x is along the green diagonal, and 500 times x minus 1.8. All right. Let's continue up here. So I'm going to distribute the 500. And let's grab my calculator. $500 times 1.8 is 900. Should have known that. All right, so if I subtract 500x from each side, I've got negative 5x is equal to negative 900 divided by negative 5. And I'll get 180. And minus 1.8. 178.1. This has units of miles per hour, and this has units of miles per hour. All right, so what have we just found? Well, I believe that we have just found what they were asking for, the rate of each car, that the rate of the winning car was 180 miles per hour. And the other car, 178.1, no, 0.2 miles per hour. And we've put miles per hour up here. All right, well, that's it. Hey, I hope this helps. This is the first time that I've ever had you pause the video or answer questions, so I'll try to get better at making future videos. Talk to you later. Bye.